Alright, welcome back to Pac-Man. After importing the project, we're now ready to start programming Pac-Man, but first, let's see what we have available to us in this project. So I'm going to start with the backdrops. So the backdrop has two mazes here, one for level 1 and one for level 2, and you can create your own levels if you want by taking these two as an inspiration. Then we have our sprites, our favorite character Pac-Man with a bunch of costumes with the mouth open and mouth closed, plus an additional costume that will serve as a collision mechanism. I'm going to talk about this in detail when we make Pac-Man collide with the walls. Then we have our enemies, our ghosts, with a bunch of costumes for Inky, Blinky, Pinky, and Clyde, plus some additional costumes for the ghosts on the run and the ghost dead after Pac-Man touches them after being on the run, plus the same collision costume that I'm going to speak about when we make the ghosts collide with the walls. Then we have power pills, which will grant me the power to chase up ghosts, and we will place these power pills strategically throughout the maze. Then we have fruits, and we have quite a lot of costumes here. I'm just going to use the costumes for the cherry, and this fruit sprite will grant me an extra life. Then we have overlays, which will have a bunch of messages. Game over, space to start, ready, level complete, and life lost. And finally we have the dots, which we will disperse around the maze. We currently have a single dot, but we will create a whole bunch of clones throughout the entire maze. Now, for this game, I'm going to assume that you already know most of the techniques that we discussed in the entire course. So I'm going to go through the code a little bit faster, assuming that you already understand what's going on. Some more complicated mechanisms I'm going to spend more time on and explain in detail, but otherwise I'm going to create these scripts without getting into too much detail into what each and every one of the blocks does. Alright, so I hope you're ready because it's going to be a fun ride. I'm going to start with the Pac-Man sprite, which I'm going to position right over here at almost the center of the stage when the flag is clicked. So I'm going to bring in when flag clicked, and for motion I'm going to go to x equals 0 and y equals -80. And then I'm going to make it point in direction 90, so towards the right in its natural direction, and I'm also going to make it visible on the screen. So I'm going to bring in the show block. Good. Now my focus is going to be moving Pac-Man inside the maze. Now, unlike the previous games, this is going to be a bit of a challenge to program for a couple of reasons. First of all, Pac-Man can only move in one of 4 directions, either up, down, left, or right, or simply stationary. It cannot move in any other direction. Secondly, and this is going to be the biggest challenge, Pac-Man is only permitted to move inside the maze. So it cannot be, for example, here in a corner of the wall. Pac-Man can only move in the black zone of the stage. So I will create a couple of variables that will dictate how and where Pac-Man is moving. So I'm going to go to variables and I'm going to make 2 variables private to this sprite. First of all, I'm going to create a variable called speed because Pac-Man moves at the constant speed throughout the maze. And originally I'm going to set speed to a value, say 2. So it's going to move 2 steps in any one direction, either up, down, left, or right. And I'm also going to make another variable called direction. Again, private to the sprite, so for the sprite only. And this direction will specify where Pac-Man is going. And this direction will have one of 5 values, either stay, up, down, left, or right. Now, depending on this direction, I'm going to change Pac-Man's coordinates. So I'm going to add a small forever loop here, and I'm going to check if the direction is up, I'm going to change its y position by a positive value. If the direction is down, I'm going to change its y coordinate by a negative value, and so on and so forth. So I'm going to add 4 if statements. So if, and I'm going to go to operators and bring in the diamond-shaped equals sign, and from variables I'm going to bring in direction. So if direction is, for example, up, then I'm going to change the y coordinate by a positive value. And because I've set speed to 2, I'm going to bring in variables and I'm going to pull in speed. So change y by speed. Then I'm going to duplicate this. So if the direction is down, then I'm going to change y by a negative amount. So I'm going to need 0 minus speed, so negative speed. And then I'm going to duplicate both of these again. And if the direction is left, I'm going to change x by 0 minus speed. So I'm going to move this sprite towards the left. So I'm going to go to motion and change x by 0 minus speed. And if the direction is right, then I'm going to change x by a positive value. So change x by speed. So I'm going to duplicate speed and I'm going to bring this here. So let me set the direction to some kind of value. I'm going to go to variables and I'm going to set direction to, for example, right. So if I hit the flag, notice Pac-Man is moving in the right direction. If I set the direction to up, Pac-Man moves in the up direction. Now we need a mechanism to change that direction. So I'm going to bring another when flag clicked block. So you remember that both of these scripts will be executed when I hit the flag because they both start with the same thing. So in the second script, I'm going to bring in a forever loop and I'm going to check user input. So if the up, down, left, or right keys are pressed, I'm going to change this direction variable. So I'm going to bring in an if block, and from sensing, I'm going to bring in key, say up arrow is pressed, and if the key up arrow is pressed, I'm going to set that direction variable to up. And then I'm going to duplicate it. So if key down arrow is pressed, I'm going to set the direction to down. And I'm going to duplicate both of these if blocks, and if the key left is pressed, set direction to left, and the key right arrow is pressed, set direction to right. So you got the picture. The second script will be in charge of changing the direction, and the first script will be in charge of acting on the direction and making the sprite move. So now when I hit the flag, notice that Pac-Man is in the up direction, but if I hit any key, I can change Pac-Man's direction by up, left, down, and right. So Pac-Man will move on its own when I press a key. I don't have to continue pressing a certain key to make Pac-Man move. Alright, so this is pretty cool. We are restricting Pac-Man's movement to only one of the 4 directions, up, down, left, and right. This is awesome. Good. Now, we need to apply a different restriction now to make the Pac-Man only change the direction when it's allowed to. And for that, I've brought up the complete project here. And you probably notice that the dots in the maze are separated by an equal distance, both on the vertical and on the horizontal. That distance is 16 points. So I'm going to program Pac-Man to only be allowed to change its direction if its coordinates are a multiple of 16. So here's how we're going to do that. I'm going to bring in a big operators block, and I'm going to bring in an AND operator, and I'm going to bring in 2 equals blocks. Actually, I'm going to bring in 1 because I'm going to duplicate it. And here's how I'm going to implement that. I am going to say x position mod 16, which is the remainder of the division of x by 16. So if the remainder of the division of x by 16 is equal to 0, then that means x is a multiple of 16. So I'm going to say x position mod 16 must be equal to 0 and on the vertical axis as well. So I'm going to duplicate this and I'm going to bring in y position. So if both the x coordinate and the y coordinate are a multiple of 16, then Pac-Man is allowed to be changed in direction. So I'm only going to allow this setting of direction if this operator here that I've constructed returns true. So I'm going to bring in a big if block, and I'm going to wrap all these conditions. So if, and I'm going to bring in my operator now. All right. So if the x and y coordinates are a multiple of 16, then I'm allowed to change Pac-Man's direction by pressing up, down, left, or right. So let's see this in action. If I'm hitting the flag, notice that Pac-Man is going up, but I can only change the direction if the Pac-Man is at a multiple of 16. I cannot change its direction in any other way. So this is a good restriction. This will always allow Pac-Man to move inside the maze if we want, but at this point, Pac-Man will also go through the walls. We'll fix that very shortly. But at this moment, Pac-Man is only allowed to change its direction if its coordinates are a multiple of 16. This is great. Now, before I wrap this video, I want to tell you something that's pretty important. The speed value must always be equal to either 2 or 4 or 8 or 16. Why is that? Well, if you set speed to another value, say 3, then Pac-Man will only move in increments of 3. So, for example, if Pac-Man moves in the right direction, x will move in increments of 3, starting from x equals 0, then x equals 3, 6, 9, 12, then 15. And then the next x position is going to be 18. So Pac-Man will miss this condition that will allow us to change its direction. Let me show you. So notice that Pac-Man is not able to move in any direction I want except in very, very large increments after Pac-Man moves 16 steps of 3 points each. That's the only way that Pac-Man can pass this condition. So make sure that your speed value is always 2. Some acceptable values are 4, 8, and multiples of 16, because Pac-Man will be able to change its direction at every step. There are ways to fix that, and there are techniques to allow Pac-Man to change its direction no matter what you put in for the value for speed. But that would make the code extremely complicated. If you want, ask me in the course Q&A, and I'll do a bonus video that will explain that in detail. But for now, set speed to the value 2, which is the optimal value for this game. So let's continue refining Pac-Man's movement in the next video.